well, this job failed, all I have to do is retry it. I don't have to figure out how to clean up that state, because if it didn't increment the counter, then that's the only thing it could do. So I can just go back and run the exact same thing again. So as I said, the main thing there is to keep them small. There's actually some recent examples I have of this that were by some newer Python people, and they didn't really understand how Celery was working and all this. And what we ended up with was this complex mess of Celery jobs that would take 90 seconds to execute sometimes several minutes. And then it becomes very obvious when none of your workers can do anything else. And with Celery, basically what it does is when you say you have 5 queues, it's going to reach out and it's going to get jobs from the first queue. It's going to give those to its workers. It's going to complete those. It's going to reach out. It's going to get jobs from the second queue. Rinse and repeat. So it's going to like step through the queues and get various jobs, right? Now the problem is if it can't step through those queues, you've hit the same problem you had before, to where one queue is backing up all the other queues. And then you end up in this kind of annoying operational situation where you have to say, well, I need this Celery instance to only consume from these queues, and this Celery instance to consume from the queues that none of my jobs are ever going to work in. And it actually becomes very quickly a nightmare to maintain. Again, like a very terrible example of something I was just talking about. Maybe you have all these events, and you're just going to say, like, oh, I need to process all the events. The queue is asynchronous. Just put it in a job in there. But this could take, hours to run, right? And a simple thing, again, is to break that up into smaller jobs. And this is actually a pattern we've used a lot. If you can imagine that this is the Django ORM, event is a table. And what we're doing here is we're batching up rows over and over. Very simplified example, obviously. But the idea here is that the task, maybe it grabs 1,000 rows, fires off those jobs, and then it repeats itself by firing another task. And that means that all the other workers, again, can finish this task, move on, do the next thing, and come back to this when they're ready. So another big thing, a lot of these are kind of like denormalized views. Counters, we're not saying select the count from the database. We're probably saying like anchor in Redis or anchor the value in Cassandra or something that's not our main data set. And like the big thing here is this is just a cache, and if you have there's these trade-offs with caching, and you have to understand like when you need it and when you don't. You don't need caching if your application is slow. You need your application to be fast first. You need caching when your database can't handle the load. That means that it is fast, but you have enough traffic on it that you can no longer just scale it by throwing more slaves at it or by throwing queries at it. It's also important that you're caching things that change infrequently. And this is kind of hard because generally when you implement caching, you're implementing it at a larger level. So for example, Discuss has this long tail problem where you have all of our blogs that get some traffic every so often, and then you have CNN, which gets way too much traffic. And you need to kind of cache CNN, but you wouldn't necessarily need to cache your blog. So actually knowing that logic and figuring that out when you're dealing with the cache is kind of challenging, to the point where most people don't, and then just saying, well, if most of the requests go to CNN, we're okay with missing all those other requests from the cache. And this is actually important. I said the cache is not to make things faster, and this is very true. It's to scale it out more. So you're going to expect slightly worse performance. Like your database can handle returning objects in memory very, very fast, just as fast as Memcache can. But now you're going to have to deal with going through Memcache, and potentially that means you're going to have to do Memcache, hit a miss, and then go to your database for another read. Anyways, Memcache is very simple. You can actually use Redis for this as well. There's some caveats on both sides. Generally, you set up consistent hashing. You have a simple ring of cache servers, and certain requests are routing to a select server. One server drops out, it doesn't matter, you just don't get any of those objects from the cache. So specifically I'm talking about an object cache here. And in this case, maybe we're looking up a list of events, right? And so maybe we're really trying hard to not hit that database because it can't handle it anymore. So we've cached the list of event IDs. It's actually let's start with, we cached these 10 events, right? But the big thing here is when you cache the actual objects, for example, and they're in this arbitrary key, say it's here's my 10 newest objects. Now let's just say you're Flickr, and you really can't have porn on your website. So if all of a sudden somebody uploads a photo and it shows in this 10 latest objects, how are you going to invalidate that cache? How do you know that that bad image is in that set of 10 objects? Anyways, so one solution I like to talk about is by just making those objects their own individual cache items, and I call this object caching. So in this case, we're going to actually, we might still cache that list of the 10 newest, but maybe it's just 10 IDs. So it's like event 1, 2, 3, 4, 5, right? And then what we're going to do is we're going to have another cache key for each one of those objects. Hopefully, we don't ever have to hit the database here, same goal. But the idea is that all you would have to do is invalidate one of those objects in the cache key. So you get back your 10 objects from the cache by doing these multi-calls. One of them either doesn't exist or it's been set to this invalid state, which kind of it tells your app, and it's arbitrary, it's whatever you want, but it tells your application this object either should not be here or you need to look at the database to confirm it still needs to exist. And then when you have that list of 10 items, well, one of these doesn't exist. And depending on your application's needs, maybe it's okay to just show 9 items. Otherwise, you can reach out for another one, right? Anyways, that's the fundamental goal with this. Simple code here. Maybe you have something that's I have that event model, imagine that again, and I want to get all of the objects by the set of IDs. There's a get multi-call in Memcache. It's going to reach out to all the servers. It's not necessarily ideal. And it's going to pull back any objects matching those keys. In this case, we're going to say, well, were any missing? And if there were, we're going to pull those from the database and we're going to reset those in the cache. And now this kind of works, but one of the biggest issues with caching is the push-pull model. Generally, you don't want to do this. You should assume that all things are going to be in the cache, otherwise you're going to have problems. You can read up more on this. It's called the stampede effect or thundering herd. So what we want to do is actually push everything into the cache. And there's a few ways you can do this. So generally, a lot of us use model layers or some abstraction to our database, and what we always do is when you're saving an object, right then and there we push it back into the cache, or we try to fire something to update those caches. When you're deleting an object, you can kind of do the same thing. You can either choose to delete it from the cache, which might work for your application. If it says it's a miss, you just assume that it doesn't exist. Or you can set a tombstone, which kind of implies your application that this has been deleted. I don't need to look it up because the cache was a miss. So a lot of this has capacity issues, right? If you start doing all of this, eventually you're just going to have all this stuff in your cache, and it's not going to make sense. You're going to start evicting all the stuff that actually needs to be there, and most of these are going to be a miss. So a lot of this, we need to plan for how we're going to scale out, and it comes back to that same thing. We need things to be predictable. So one of the largest issues that, in my opinion, some people might disagree with me at Discuss, but one of our largest issues was this moderation panel. This is a nightmare to make work well in Discuss. So the problem here is it's a simple list of comments, which might seem trivial, but it also allows you to say, I want to see only approved comments, or I only want to see pending comments. Pending is kind of this arbitrary state as well. It's not a real state. And then even worse is you have this view for a site, like my blog, and then if I'm a moderator for some other sites, you also have this view for all of the sites I moderate. And now this becomes very, very hard to deal with because there's constantly data coming into this. The pattern for how I get the data out is kind of varying, because in one case I might be just getting my blog, which is pretty simple, right? But then in another case, I might need my blog and CNN, or this other guy on CNN actually might just need CNN, or he might need CNN and, I don't know, for whatever reason he also moderates Fox News. And that becomes very hard to optimize because you can't just easily write everything to a list in this case because it's very expensive at that point. I would like to give you solutions, but this is a harder problem at scale. But it was mainly a problem because we didn't plan ahead for it. But the thing I want to talk about is the complexity there. That used to be actually a much harder problem to discuss, and all we did was simplify it to make things better. Another example of something that was pretty bad at Discuss, and this is entirely my fault, was our API and the numerous endpoints it provided that you could do odd querying behavior. You could say, I want all the posts from this website and from this web page and from this user, and these complex queries where you'd have to chain logic and stuff, and it's impossible to optimize any of that. Now, for example, if you look at Twitter, and they said its API is more well, I want the timeline of this user, or I want the mentions for this user, or the profile for this user. It doesn't say I want the timeline for this user that is between this date range and, I don't know, maybe only includes this hashtag. And while it does via search, it doesn't via the traditional API. And that's actually important because that's a scalable solution, whereas this is impossible to deal with. So the lesson here was be mindful of what we're doing. Sentry's kind of, I want to say, sort of done a good job at this. We have a team dashboard. So a team in Sentry, it's kind of like a GitHub organization. You have many projects under an organization. So we have a dashboard, and this is the only place where we aggregate data for a team level. And this is important because the dashboard is very simple. It has a chart, and it has two simple views that show the trending data and they show the new data. And these would be trivial to have a cache or to materialize in another key. And this is important because now all of a sudden, like if I needed to break up the data, like all of the data for this team could just live on one server, and other teams could live elsewhere. And we could still be do powerful things at that point. But then you hit the problem that, CNN or, a big website or something, now they're all one team and that server's too big. So you have to look at how can I optimize it and provide functionality? So we chose explicitly to only provide this functionality at a team level because this is stuff that is very easy to materialize and the data doesn't, the whole team wouldn't have to live on the same server. If you look at our stream view, it's limited to a single project, and this is, you cannot get a stream of events for your entire team in Sentry. There's no APIs that will let you do that. And this is important because now we can map every single project to a different DB, which gets us one level lower, and it's still very natural routing and very easy to deal with and understand. Now the big thing is if you're doing this, imagine if say I have 1,000 projects in Sentry and all those need to live on different databases, it gets very complex. One of the hardest problems that we had to deal with at Discuss was taking our massive monolithic single master Postgres server and splitting that into a bunch of smaller master servers. And that was a problem because we didn't pre-allocate resources. If we knew going in that, Discuss is eventually going to be big, let's set up 1,000 virtual shards or something. Then migrating the data is just well, we're going to move this one virtual shard to a physical server and problem solved. Operations are happy and everybody wins. I was talking about Redis, so I'm going to go back to using that as an example for this. So, Redis must fit in memory, which is why this is a very good example, because we have to do this with things like Redis. If you try to split your Redis data, your website basically needs to go down. And this is important because Redis is a single-threaded item. If you say, give me all the list of keys, is what they call it in Redis, that's blocking every single other operation, which is important. Because if let's just say you had one server and now you needed to split it into 10 like this, you would have to get all the keys, you'd have to basically decide where they're going to route to and then write them to the new server. You'd have to have complex application logic to figure out where am I reading and writing to, et cetera, et cetera. So instead what we do is we have 10 of these up front. In Discuss's case, we would, depending on how early we made the decision, we would have anywhere from 32 to 64 of these virtual nodes up front. And it'd basically just be in Redis's case, we just literally run 10 of the same server, or 10 of the Redis server on the same physical hardware. And if you have container VMs and stuff, this gets even easier, right? Because you could just abstract everything inside of a VM, and now you're actually connecting to different hosts and stuff, and it's very clear. And then, the big thing here is as soon as one of those gets overloaded, we can actually just split that physical hardware in two. We still have a little bit of application logic that has to deal with this. It has to say, where am I reading and writing to? Because, all of a sudden it's going from this physical machine to, that machine and another machine. But Redis also, like many things, has replication, so we can use a master-slave functionality to help us with this failover. Or we can have something in front of Redis, potentially, to help us with this failover. But the main thing here is that operationally this becomes very, very easy compared to actually trying to migrate data. So there's a lot of things that I kind of want you to leave here with. The most important is that SQL is the right solution. Actually, how many of you are using SQL for your primary data store? Okay, that's pretty good. How many of you are using MongoDB? Okay, that's acceptable. Anyways, SQL is a proven technology. It's getting better and better and better. Schemas are your friend. They are features. They make things very fast and cheap. I have examples of this I can show you with Sentry, where the parts that don't have a schema use all of the disk space, whereas the parts that do have a schema cost nothing. Most importantly, queue everything. Sentry, almost every single operation goes out in the queue and then breaks up into more operations. In fact, like, if you're a busy site, when you say, here's my error in the API, it doesn't even hit the database. It says, okay, find the authentication details from the cache. All right, I got those. And then it says, check your quota. Like, are you sending events too fast? It does that via Redis, and the simple counter's there. And then it says, okay, you can store this event. And then it just sends it to the queue, and that's it. And that makes it very, very fast. And then when that happens, it goes into the queue, and then it says, oh, well, I need to fire an email for this. I need to scrape some web page to get more information about this event, et cetera, et cetera, et cetera. But each of those can be broken down into steps, and each of those steps can be an individual item in the queue. And I think this is probably the biggest shift. And if you're not doing this from day one, you probably should. It's going to make your application much easier to scale and much more responsive. Something that's a little bit harder is learn to say no to features. And I know this isn't always possible. People always ask, well, how can I tell, in my larger company, my manager, that we can't build that feature? Generally, you can't, but you can try to reason with them and convince them that maybe there's a simpler alternative that provides 95% of the value and takes 5% of the cost. Doesn't always work. Sometimes you have to be creative, which is why we have to do any of these things to begin with. But I found PMs generally easy to work with and reasonable. Most importantly, the complex problems do not require complex solutions. I feel like everything in this deck is pretty understandable, and it's trivial to implement, and it works at, sorry, there's a fly. It works at just about any scale. And that's all I have, actually. Thank you. Any questions?
So, question time.
Thanks for the talk. That was really great. This is a bit of a detail, I think, but in some of your opening slides, you had some duplicate events, and I didn't grok where they came from.
So in Sentry, basically it hashes an event. So for Python exceptions, for example, it takes the stack trace and it tries to normalize that, and it just does an MD5 on it, right? So the duplicate events are just matching MD5s for Sentry's case. But in Discuss, the duplicate event per se might be you need to know how many comments are on a thread. A thread is a web page in Discuss, so you might need to know how many comments are on a web page. So your duplicate event in that case is just the web page, and you're grouping by the web page because that's where your counter is.
More hands?
You said you're using Memcache and Redis for basically caching. So my question is, what does Memcache give you what you couldn't do with Redis?
So Memcache is, it doesn't really matter, but it's slightly faster for the basic things, right? Memcache also has very good client libraries, which, as far as I know, none of them are compatible with Redis, which is important because you need all of the behaviors of Memcache. You need the Katama consistent hashing ring. You need this knowledge about evictions, etc. So it's not that you couldn't do it with Redis. It's just that the client libraries are very, very good for Memcache. We made some effort into writing some of this code, not all originally ours, in the project I was talking about, Nidus, for Redis. But it's just another level of stuff.
Could you go back to the slide when you have this save operation? Because I was at the beginning, so I am not sure. So Discuss is based on which framework?
Django.
Django, oh yeah. So in Django, you get this operation. It's like you prepare every operation you override with making the cache. But can you make them for all of the group, or make it easier? Not to write for some model, yeah?
But make it work for kind of every model?
Yeah.
Yeah, you definitely can. We actually do. And there are some open source projects that do this. I forget what they're called, to be honest.
Right.
you could look at Sentry source code, which has an abstraction of this that's just on the manager level. And for those not familiar with Django, the manager basically controls the access to the database. So we can actually bind all of that in the manager and say, when we're getting it, we can pull from the cache if we wanted to. When we're saving it, we can bind post-save, post-delete signals. So we handle it all through that decoupling right there.
Yeah, sounds great. Thank you.
More questions?
Great talk, thank you for that. It was a good insight. I was wondering, the more complex and the more successful a web application becomes, the more of these small tools we end up inserting in our stack, and eventually you end up with 25 different things in your production stack, maybe even Elasticsearch on top of that, because people try to search something that I can't find in Postgres, and I need maybe facets on top of that, and I put that all in a little bit of Redis, and then I have Memcached. Maybe I want to spawn a couple of Memcached and don't delete keys, so I use Katama on top of that. Then I need something else, I put Celery in, and so on and so on and so on. And I was wondering, some people go and say, right, okay, we just drop all that and we just put tons and tons of databases in and just scale them and shard. What's your opinion on that, complexity versus simplicity? We heard that in the first talk. And
I would say use it when the technology makes the most sense, and that doesn't mean that it's necessarily it doesn't mean you should use it because it's the fastest or it has the most features and maybe you'll need those, or maybe it's better than your existing solution. Maybe it only makes sense or maybe that's when it does make sense, but maybe it doesn't make sense because you do have all this investment in sharded SQL or something like that. Or if you're already using Redis, maybe it doesn't make sense to introduce Memcache if you could just store it in Redis. If you can keep your architecture simple, it's always going to be better, and if you can reuse the same components over and over. So if you could do a lot of this in Elasticsearch, then maybe you don't need something else instead, for example. Discussed early on, all we were was Postgres and Memcache, and then all we were was Postgres, Memcache, and Redis. At one point there was MongoDB in there, but nobody could make it work right, so we just threw that away and rewrote it in SQL. At one point we had Membase, and that couldn't work, or that didn't work for us, so we just threw it away and put it back into I think it's in Redis at this point. And it's just now where Discuss is growing to a much larger size and everything, where we're actually using other tools, but there's not that many of them for us. It's still, Postgres, Redis, Memcache, Cassandra, and that's about it. Maybe some S3 or something. It's still a very simple to understand stack. If you know those technologies, it's well, you can basically work on anything, which I think is a very important thing to think about, because actually a good argument is somebody introduced Closure at Discuss, and it's why does this make sense? Now people can't operate on this system because it requires understanding Closure. And that complexity right there, just to write something in a language that maybe was a little bit faster, or whatever the reason was, it doesn't matter. But the complexity introduced by having that other system that nobody understood except one or two guys, right? That's actually a big problem. And there's actually there's a guy from Yammer who, there's an article that went up recently, which is really, really good. I don't have a link offhand, but he's talking about the greatest cost to software engineers is complexity, and that people should simplify things. And it's a really good read, and I highly recommend checking it out. But I basically agree with that. The simpler solution, the better. Everything I list in here is kind of a hack if you think about it. There's a lot of complex database systems that can implement some of this for you. Why shard SQL when you could use React or Cassandra or some magical thing on AWS? Well, the answer is because it works very well, you know how to use it, and the cost is of using this other technology is so great that it doesn't make sense versus all this investment that you have in an existing technology. So I think it's always come down to choosing the simpler solution that's going to be less complex and easier to understand for people in the situation. And generally that's choose the same technology you already use until it doesn't fit. But yeah.
Thanks for interesting talk. The question is about distributed transactions between several tasks, because in Google App Engine that problem is partially or more or less solved. But do you have any recepts for that?
Not really, no. It's a very hard problem. Honestly, even getting your tasks to where you could safely re-executing them so they're idempotent is also a very hard problem. Like, there's like simple solutions you could say, like, you're going to have to store state somewhere, right? And every time you're storing state somewhere, things get more complicated. Like, we're using the queue to store a lot of that state for us and hoping that it can safely say, well, like, this job has been executed, this job hasn't. So at least we have that level of, like, insurance. But then if you need to say, like, in this job, if I need to increment this counter, and in this job, I need to do something else, but if this one fails, I need to roll back that. Like, that becomes a very complex problem. And I would say, like, try to avoid that case is, like, your best bet. And if you have to do that, then you're going to have to track the state of it somewhere. And you're going to have something that monitors that state and cleans up after it and things like that. So it's like, I think at that case, it becomes a less, the solution is more specific to your problem, and it's a less generic thing. But I don't have anything great for it.
More questions? No? Okay, so thank you again, David.